I'm Dick Moberg, and for more than 40 years I've been developing technology to advance our understanding of the injured brain. I've had a chance to work with some of the leading minds in the field of neuromonitoring, including physicians, researchers, and entrepreneurs. I want to share their stories with you in the form of a weekly podcast so you can stay current on the latest developments in the field and the innovative people behind them. This is my neural network. A quick note from the team at Neural Analytics. Some of the topics described during this podcast are Neural Analytics research initiatives and do not necessarily reflect or describe the company's commercial products. And now, on to the show. I'm Dick Moberg, and here we are at the Military Health Systems Research Symposium, and I'm with the Neural Analytics folks, with Seth Wilk, who's VP of Research, and Corey Thibeault, who's Director of Data Science. Welcome, you guys.
Hey, thanks very much for having us.
Yeah, thank you.
Cool. Yeah, it's great to be here. You know, I go way back in TCD, and some of the early guys there, like Merrill Spencer and Rooney Oslett and Dieter Dinner, were all buddies of mine. And back then, in the late 80s and early 90s, there was a lot of innovation coming out of TCD. I remember the early emboli detection algorithms were out there, and a lot of other things. Pulsatility index was invented. It was pretty exciting. And then over the last, probably the last 10 or 20 years, it's been sort of flat in terms of innovation. And but we hear a lot about Lucid and neural analytics, and you guys seem to be turning things around with the innovation. So what's that all about? Do you want to talk about that, Seth?
Yeah, sure. So I could talk about it a little bit. You know, basically, the company was founded on understanding what was in the TCD waveform. And so we were very excited because we felt that there's all this information, and the information being put out was actually very traditional and, you know, mean and velocity, pulsatility index. And if you look at those waveforms, there's a ton of morphology in there. So the company was founded based on that idea of innovation and that we could develop something out of these signals to learn more from it. So that was kind of the original premise was, hey, let's make this new innovative idea and let's build out what we're going to do with TCD. And so that was the start. So that was the beginning of the innovation. But then what happened was, if you look at TCD signals, they're a little harder to measure. And so a lot of times you need a trained sonographer. And so the next thing that came out of this was that, well, maybe we can reduce the need for the trained sonographer at all times. And what we could do is develop a robotic system that would completely automate TCD. And so that's the other piece of, you know, innovation that we've worked on, where we've developed a system that moves like a hand and can perform the TCD for you. So yeah, I think that's a good summary of high level where we're at, or at least how we started. So
that's really cool. And Corey, I heard a talk that you gave yesterday at this meeting, and that was pretty cool. Can you give me a little information on where you're headed with the waveform analysis?
Yeah, I mean, the talk that I did yesterday was on MTBI, and that was actually using more traditional techniques, sort of actually what you were talking about before, and far less of the advanced morphology that we're talking about, or that Seth was talking about. We believe that TCD has been an underutilized technology, and in particular, in the case of MTBI, there were very few people sort of looking or exploring that area, and not many people believed that you'd actually see changes in hemodynamics. And so the talk yesterday basically was demonstrating some of our early research, showing that you can actually see some of these variations, even using traditional features like you said, PI or CVR metrics, and see changes in the recovery of concussion patients. And then more of the advanced stuff that we're doing that we haven't published as much on is doing the more advanced waveform analysis and applying machine learning to that in order to get a better diagnostic out of there.
So Seth, I'm here looking at this robot on your table here. It looks pretty cool. Tell me a little bit about it, and what does it do, and where do you see it going?
Yeah, so we're very excited. This has been a big development effort for our company. And so we have a really talented product development team that has worked to take the concept of can you roboticize TCD into actual fruition, right? And so what the device does and how it works is it basically uses fiducials to register on the head. so that you can have an idea of a starting point of where the TCD window is. And then you use regular ultrasound gel, you push the probes up against the head, and they're the normal TCD ultrasound probes. And what the robot does then is it searches around the side of the head to find a window. And so what's nice is we could start to use some data analysis techniques and have an idea of where windows sit on different people. And so we can use that to basically give you a starting point. We then search, find a window, and then the robot will use different methods. So it looks at the quality of the signal and the velocity of the signal to really optimize on the MCA waveform. So it's a nice way of doing it because essentially you put gel on, register, and then you can hit a search button, and then the robot will look for that signal. And so then, where we're at right now and what's exciting is that we also have a regulatory team that has worked with this device to push it through. So we have a recent FDA clearance on the device to be able to use it to measure and monitor blood flow. So it's a combination thing that we're excited to be able to push out. And it's fun to see the robot work, especially for Corey and I think we've been at the company 4 or 5 years, and from the original talks and the early prototypes, we've gone through numerous prototypes of this to where we're at. It's been exciting to see.
Yeah, that's cool. I visited you guys last year, and Aaron put this on my head, pushed a button, and did an exam on my head, and that was pretty cool. So that addresses a lot of the workflow issues in TCD, and you've just cut this way down from a normal exam to something that can be automated. Let's talk next about where do you think you're going with the machine learning? I think you guys are really doing much more in that area than any other TCD company I've known. So where are you headed with that? You want to take a crack at that?
Yeah, sure. It's been interesting. I've built out this team of sort of very brilliant scientists who have been sort of chewing at the bit to apply some of these very advanced machine learning techniques, and yet the approach we've taken so far has surprisingly been very foundational. We've used very sort of basic analysis techniques, and we're sort of building this physiological foundation for TCD that didn't exist before. And so we're now taking that much further and deeper into the diagnostic phase now that we feel we have enough evidence to convince a clinician, for instance, that you can diagnose a concussion or you can track a concussion with TCD, and you can estimate ICP. And so now we're going what we like to call the black box approach. We're applying these advanced analytics, and we're allowing some of the higher order mathematics to allow sort of extract the signals out on their own and get us a much higher performance and a much more robust diagnostic capability than we've had before.
Yeah, that's cool. Concussion is sort of it's a really tricky thing to get metrics on. I have a lot of experience in more in severe head injury, and you can instrument a patient, like almost like you're in a lab. You have probes coming out of their head and you get a lot of data, but concussion, you can't do that. So it has to be non-invasive, and everybody's that's sort of the holy grail, I think, and certainly for the military and for clinically. What do you think? What is your guess as the role of TCD and concussion in the future? I mean, as opposed to some other metrics like EEG and other people that are looking at that. What's your hope?
I mean, I'll start off by saying, concussion is probably the worst thing we could be trying to start off with. And it's, to be fair, we're not starting off directly with that. We are focusing much more on things like stroke, LVO detection, emboli. Concussion is a big part of our research, but it's sort of further down the line. But in terms of sort of TCD's place in the world of concussion treatment and within the clinic, it's sort of it's a complementary approach to what already exists. I mean, given the heterogeneity of any of these injuries and of people themselves, it's gonna take a multimodal approach to really not so much solve the problem, but really attack the problem where we exist right now. And so the nice thing about our device is it can work with an EEG system as well. It complements the signal that you get there. It will work with the eye tracking systems as well. And like you said, because of the non-invasive nature, it can be used at the point of care by clinicians in office. It can be used eventually someday on the sidelines if you want, or in the field. And so it offers a different signal, and it offers a complementary signal to what's out there already.
Yeah, I agree with the multimodal approach. I think with something as complicated as the brain, that's where the money is. I don't think any single measurement can do this. So glad to hear you say that. Well, that's great. So, Seth, what can we expect from neural analytics in the next year or so?
Yeah, so that's actually a pretty good question. You're asking the research guys here, so normally we're not looking at 1 year, but let me start with longer than 1 year, if that's all right, because we've had some really exciting funding opportunities, from the NIH, NSF, from the Department of Defense, CDMRP. And so this is really funding some of that research that's going to really push the forefront of TCD and its ability to be used as an assessment technology, not only as an assessment technology, but one that's easy to display and one that's easy to understand, and take it from, a little bit more of a research situation to a commercial device. And so then that was the second piece that you're asking for what's going on in the 1 year time frame. And so we're very excited because we now have clearance on the base device to be able to measure cerebral blood flow velocity. And so we're developing and putting together the commercialization team necessary. And so we've got a great team right now. They're out there at the hospitals. We're doing eval units and all this kind of great stuff to really push TCD and to show that the robotics are a way to extend its capabilities. So yeah, we're really excited about the growth and the possibilities and really the overall team that we have to be able to do this. So yeah, thanks.
Well, that's great, and I wish you a lot of luck in the next few years. I know what it's like to be at a startup. I've done it many times, and really good luck. I know a lot of people are rooting for you. Thanks very much. So thanks for listening to this week's podcast. If you enjoy these interviews, please take a moment to rate and review this show on your podcast app of choice. Subscribe to Dick Moberg's Neural Network to receive notifications when future installments are available. Thanks for tuning in, and we hope you'll join us again soon.